the introduction, probability is a fundamental concept in mathematics and the measure likelihood of an event occurring. It is widely used in various fields such as statistics, finance, science, and everyday decision making. One of the simple and common ways to explore probability is through the random experiment like tossing coins. In this focus on understanding both experimental probability and theoretical probability through the act of tossing a coin. The coin toss has two possible outcomes, which is head or tails. Theoretical, each outcome has equal chance of 50%. However, actual outcome of the repeated trial may vary due to chance or external factors, and this variation forms the basis of a study experimental probability. In this experiment, a coin was tossed 30 times, and the outcome were recorded to analyze how closely the experimental result aligned with the theoretical probabilities. The activity aimed to strengthen student understanding of probability concept, develop analytical thinking, and highlight the importance of surface data in estimating probabilities. By comparing experimental outcome with the theoretical expectations, the study provides valuable insight into real-world application of probability and the concept of randomness.
Assalamualaikum and hi, my name is Nur Syuhada binti Zainul Zaman, matrix number 2023497828. Here are the objectives of our experiment. First, to record the possible outcomes of tossing a coin, specifically how many times we get head or tails in 30 trials. Second, to determine both of the experimental and theoretical probabilities of getting heads and tails based on our data and mathematical expectation. And third, to identify the difference between the experimental probability and the theoretical probability for both outcomes. This helps us to understand how close our real results are to what we expect in theory. For this experiment, our goal was to compare the experimental probability of tossing a coin with the theoretical probability. We begin by preparing a fair coin, a table for recording outcomes, and assigning group roles. Our one group member was in charge of tossing the coin, while the others recorded the results. We tossed the coin a total of 30 times. After each toss, we immediately recorded the outcome, either heads or tails, using tally marks. We also kept track of the full sequence to ensure accurate data. Once all 30 trials were complete, we count the total number of heads and tails. Then we calculate the experimental probability using the formula P equals the number of times the event occurred divided by the total number of trials. After that, we compare the experimental result with the theoretical probability, which is 0.5 for both heads and tails, since a fair coin has two equally likely outcomes. Finally, we observe the difference between the experimental and theoretical probabilities and discuss possible reasons for the variations, such as randomness or small sample size. For question A, we record the outcomes of 30 coin tosses. The sequence of result was written down, and we used tally marks to track the number of heads and tails. In total, we got 17 heads and 13 tails. For question B, we calculate the experimental probability of getting heads. We use the formula P equals the number of heads divided by total trials. So P heads equal to 17 over 30, which is approximately 0.5667. For question C, we calculate the experimental probability of getting tails. P tails equal to 13 over 30, which gives us approximately 0.4333. For question D, we state the theoretical probability of getting heads, which is based on the assumption that the coin is fair. Since there are two equally likely outcomes, the probability is 1 over 2 or 0.5. Finally, for question E, the theoretical probability of getting tails is also 1 over 2 or 0.5 because it's the other possible outcome of a fair coin toss.
For F, what is the difference between experimental probability of throwing head and the theoretical probability of throwing heads. First, experimental probability of heads equal to 56.67%. Then, theoretical probability equal to 50%. And then, lastly, 56.67% minus 50% equal to 6.67%. And for G, what is the difference between experimental probability of throwing tails and theoretical probability of throwing tails? First, experimental probability of tails equal to 43.33%, then theoretical probability equals to 50%. For difference, 50% minus 43.33% equal to 6.67%.
Okay, next about the set question. The question will be let y be a continuous random variable with a probability distribution, and it was the question. So first question, they want me find a value of m. So I will use integration. So integration y squared dy plus m minus y dy equal to 1 because they want to find a value of m. So I simplify the question and I will get m equal to 13 over 6. The next question will be find p y less than 0.5. I simplify there, use integration 2 and y square integration, the top is 1, the top was 0.5 and the bottom 0, y square dy, and simplify and I will get 1 over 24 or 1.14167. The last question is calculate ex plus 2. Ex was a mean and e2 was e2 is a variable. So to find the ex, I will use formula x times fy dy and I will simplify and I will get ex equal to 7 over 6. To simplify the question, ex plus e2, I will get 19 over 6 or 3.167.
Lastly, for the conclusion, in this experiment, a coin was tossed 30 times, resulting in 17 heads and 13 tails. The experimental probability of getting heads was approximately 56.67%, while the probability of getting tails was approximately 43.33%. In comparison, the theoretical probability for both heads and tails is 50%. The difference between the experimental and theoretical probabilities was 6.67% for both heads and tails. This small difference is due to random variation, which is expected in a small number of trials. This demonstrates how probability works in practice and how results can vary from theory in the short term but tend to align over time.